This is a very short section too for that chapter 13. I have to cut it in 3 parts because the file would be too long. So what I'm going to look at is mostly some of the common names you should know about alkene and alkyne. I'm not asking you too many of those. You'll see later that we have to go back to historical reasons. And there are a few alkene as well as alkyne where we don't use actually the IUPAC rules, but they have a common name. For example, here the one you should know, a 2-carbon alkene and a 3-carbon alkene. One of them is called ethene. We actually call it ethylene. The other one, the 3-carbon alkene propene, is actually usually called propylene. And for the alkyne, the simplest one, the one that is ethene, most of the time we call it acetylene. And you probably heard of those names. Now, what I want to insist on that section is the cis-trans isomerism. Now, the difference between alkene, alkynes, and alkane is that they have a double or triple bond. Okay, so that double or triple bond is what links the 2 carbon atoms and prevents those carbon atoms to be able to rotate one to each other. So in other way, what we're looking at is we have actually all that molecule that has sides, and ends, and this is because they are going to be in a plane. So if you look at this figure, ABED, in between the carbon atom, where you look at AB and ED, you can't make them turn. You can't replace ED with E on the top and just make it turn so E is at the bottom. So that's the reason why you have what we call a cis or a trans isomer. How do you recognize each other? Well, I try to make a little bit simpler to remember. So cis, CIS, I would think same side, SSI. I don't know if it helps or not. Trans, just think transversal, going across. Now, those examples here, you see the cis configuration. We have 2 CH3 on the top. They are on the same side of the double bond, so that becomes a cis. If those were across, CH3 on the top right and CH3 on the top bottom left, they go across. That makes it a trans. Some example, okay, here you could not have a cis trans on the first example because on the left carbon you have 2 hydrogens, so it doesn't matter which hydrogen is on the front or on the back, it's still an hydrogen, so there is no possible cis trans isomerism. Now, bottom example, of course, here is different. I have a CH3 that is going to be on the front and both hydrogen from the 2 carbon on the back side or across makes it a cis-2 pentene or a trans-2 pentene. We look at those here where they are, again, same side is going to be cis and across is going to be trans. We use them in different ways, relative term to indicate how various groups are attached to that double bond carbon, and also to indicate how the longest chain in the molecule goes in, through and out of the double bond. And that's it for that second part.